My name is Avinash Kumar. I am from NIT Raipur. Today I am going to present my paper, which is titled TOPSIS-based feature selection for text classification in this conference, which is third international conference on pervasive computing and social networking, ICPSCSN 2023. Now, these are the contents. First, an iterative slide, then introduction, literature subject, proposed methodology, resulting discussion, inclusion and feature scopes, and then references. Now, United Raipur, the institute is of national importance and situated in the city of Raipur, which is capital of Chhattisgarh state. It is connected to one of the tier one metropolitan cities like Mumbai, Delhi, Chennai, Visakhapatnam, etc. The institute has an autonomous institute and fully funded by MHRD. The institute is more than 60 years old. Presently, it offers BTech program in 12 discipline, Tech program in 10 discipline, and including MCA and applied geology, and PhD program in all disciplines of engineering, science, humanities, and social science. To get admission in IIT Raipur, we have three entry criteria: BTech, MTech, and PhD. For BTech, one has to clear JEE mains, get admission. One has to appear for BEd and social CMT to get admission. And then for PhD, they have to go through written test and personal interviews. For any further inquiry, one can email to team at NIDR. And it also gives admission to foreign nationals. So that's now to our medical thing. So, what is text classification? Text classification is the process of automatically categorizing text into predefined categories or classes. Text classification has diverse applications, including news classification, social media post analysis, sentiment analysis, of rating and reviews, and many more things. The dimension of text classification is rapidly increasing, driven by a wide range of applications, which create the challenge of dealing with high dimensional data. The dimensionality of data can expand in two methods. One is through the increasing number of features, and another one through the increasing number of symbols. High dimensional data could lead to problems such as curse of dimensionality and computational complexity. Curse of dimensionality, if you take a minute to understand, then this is the thing where if the number of features is rapidly increasing, then there may be the chance that the model prediction rate or accuracy rate could be lower because model have to learn a lot of things now. So, so the features are increasing, but the performance of the model getting decreased. That's why this is called curse of dimensionality. So in order to make it more accurate and more precise, we need to reduce the number of features. That is our challenge, that feature selection can be used to address the challenges of high dimensional text data. Now, these are some of the papers that I have gone through. First one is titled on the integration of similarity measure with machine learning models to enhance text classification performance. In this paper, they have used 14 similarity measures and they have integrated them with two classifiers. One was neighbors and the other was SP. And they came out with a nice result. In this paper, the author has written addressed the issues related to class imbalance problems, feature extraction, and classification in textual data. Also, I found that the feature selection problem was not addressed in this paper. So if we could do feature selection in that problem, the accuracy and precision could be better. Now, in the second paper, this is methodology of combining cosine similarity with classifier for text classification. Similar to that, in this paper, they have used only cosine similarity. Now, the author has focused on combining similarity measure with classification model to improve accuracy. So here, feature extraction have been focused more in this paper. And feature selection problem had not been touched. Similarly, in paper 3, which is titled A Recent Overview of State-of-the-Art Element of Text Classification. This paper author has extensively discussed feature construction, feature selection, training of a classification model, and solution evaluation. But the issues related to streaming data is not discussed in this paper. Streaming data, we mean to say that the continuous data that flows and most of the time, machine learning is used to predict the static data, which means we are already having the data. But streaming data is the data which is continuously coming. So that type of challenge is not being discussed. Now, in the fourth one, a comprehensive survey on feature selection in the various fields of machine learning. In this paper, the author has addressed the challenges of real-world feature selection problem and has provided a comparison of different feature selection technique and their and in this paper provide an overview of existing research on feature selection in machine learning and its application. And this is a survey paper, so that's why this doesn't have practical implementations. So this paper lacks here, but this provide a good overview of already existing methods for feature selection. Want to understand feature selection methods in a better way. Now, the fifth paper, it's titled Evaluation of Feature Selection Methods for Text Classification with Small Data using MCDM methods, which is multi-criteria decision making. Has been published in Applied Computing Journal. Now, in this paper, the author has implemented MCDM method for feature selection over small data sets. Now, MCDM method is used to solve the problem related to high dimensionality of data. However, author has validated some small data set in less MCDM methods. So I found out that they could have implemented more methods. There are several MCDM methods like TOPSIS-based and other data set that this author has used this theory. Now, based on these papers, the research gap that I have found is due to high dimensionality of single level text classification data. There is need for exploring filter feature selection method. This is because filter method have low computational complexity. As we earlier saw that due to the increase in the number of features and sample, computational complexity also gets increased. So, and the filter feature selection method is a method which have less computational complexity. So, we need to implement a filter feature selection method which would be taking less computational complexity and providing us with better results. Now, the objective is to design single level filter feature selection method for single level text classification using any MCDM technique. There are a lot of MCDM technique we have to do using that. So, TOPSIS is an MCDM technique. So, let's discuss what is TOPSIS. TOPSIS, as the full form suggests, technique for order of preference by similarity to ideal solution. Now, TOPSIS is a multi-criteria decision-making method that helps decision maker to choose the best alternative from set of alternatives based on multiple criteria. If we talk about MCDM methods are those which helps in which helps in selecting the less redundant and more relevant features. Now, Topsis is also an MCDM method. So this one also does that. So by Topsis, we can choose the best alternative from set of alternatives. Topsis method is based on the principle that first alternative is the one that has shortest distance to the ideal solution and longest distance to the worst solution. Based upon the principle, we can select the best features out of a high dimensional dataset, which is having more features. Now, TOPSIS is a simple and effective method for MCDM and is widely used in many fields such as engineering, finance, and management. And if you see the diagram over here, it is basically the flow how TOPSIS is working. So first we have the data set. We create a decision matrix. Decision matrix is basically the combination or merger of feature correlation and feature label correlation. After that, we calculate a normalized decision matrix. Normalized means we create all the null value if there is any or any negative elements. So this is normalized and null value removable. Then after that, we calculate weight of decision matrix using entropy. After that, we find positive ideal solution and negative ideal solution, and then we calculate the relative closeness because our best alternative would be closest to positive ideal solution and farthest from negative ideal solution. After that, we get all the features. Then we solve the features in descending order based on the relative closeness because we have the relative closeness there. This way, we get feature rank. So this was the thing that is in TOPSIS. Now, our proposed methodology. Our proposed methodology is dealing with text classification for single level data using TOPSIS as a scheme. Okay. TOPSIS is used as filter feature selection method to obtain decision matrix for TOPSIS. Feature redundancy and feature level relevancy is considered. Features are considered as alternatives here, and then features are ranked using TOPSIS to that our method. We are having textual data sets. We applied vector processing like stop removal and tokenization. After that, using count vectorization, we have extracted all the features. Now, feature selection. This is our method. We have applied TOPSIS, which is a feature selection technique. Now, after applying TOPSIS, we get top 10%. We have selected basically top 10% features. So our number of features have been reduced. So now classification will be more easy. After that, we have integrated some of the similarity measures with multi-neighbors classifier. Then we get the evaluation parameters like accuracy, precision, all that also. Which algorithm explains the same, which is basically an algorithm for that. Now, for validating our method, we have used four data sets. One is the vectors, which is a widely used benchmark data set in NLP for text classification purposes. It contains 8,422 news articles from the Reuters News Agency, which are classified into one of eight categories. So this data set has eight categories. Another one is movie reviewer data set, which have two levels, positive and negative, and it consists of 2,000 reviews and is having 39,667 features. Brown dataset uh, is available on NLP library, analytical library basically. And this is having 15 different categories. You can say that 15 different labels with having 52,453 features after the feature extraction. One more thing is 20 ng data file. This is having 11,340 samples with 67,056 features. and is having 20 different categories, means level contain 20 different types of groups. Now, this were the data set. To that, when we apply our proposed methodology over these data sets, sorry, we apply these data sets over our proposed methodology, then we get these kinds of results. Here, we have applied five different types of similarity measure, which is cosine, verticality, gradient, and pattern. These similarity measures or distance parameters. Now, after applying uh, these data sets, we check that without using the feature selection, what we get and the accuracy. So this is accuracy graph basically. And after applying the feature selection, what the difference we are getting. So as we can see that let's take one data set and similarly based on that the remaining are there. In the address data set, if we don't apply the feature selection method, which was our TOPSIS method, then we get 74% accuracy. If we apply the feature selection, the same TOPSIS, the accuracy got improved by 94.2%, a huge. And for all the similarity measures, we are getting improved accuracy. Here for Jacquard, we are getting a little more accuracy than the remaining one. So this was the thing. And similarly for all the remaining data sets. Now, this is the result section. This is the accuracy graph uh, of different data sets based on different similarity indexes. Also the precision graph, the recall graph. And this is the comparison among different data sets. The above one is our proposed methodology, and these remaining are the different data sets, different feature selection method that were previously existing uh, in, and I have taken these values from different papers. Now, this graph table shows in a way target. The MI method, either the plus method tries by the JMI and DNT. These were the methods that were previously existing in a paper. I have taken their value and compared with our proposed algorithm. And we can see here our algorithm is giving better accuracy than all of the existing state of the art methods. These are state of the art methods. So for our all four data sets, our accuracy is getting better. The results clearly indicate that application of our feature selection method improve the accuracy of all similarity measures for all four data sets tested on here. Performing feature selection requires selecting the most relevant and less redundant feature, which can be conflicting tasks. That can be solved by NCDM method, and that's why we have used TOPSIS here. Now, integration and similarity measure help in boosting the performance of the model that we solve. So that's why we have integrated the similarity measure. Now, when compared with pre-existing model, our approach outperforms many state-of-art method technique, resulting in average accuracy improvement of 45.59% across all the data sets and methods. Basically, we have compared all the results that we got from the result that we got without using the feature selection method. Then we saw a jump of about 45% for all the data sets combined. But this was now, in conclusion, we can say that feature selection can improve model performance. Cannot maybe say that uh, it is an essential tool for improving on model performance. It's not always true because there are some issues also the performance may got decreased, but in most of the cases the fee and the performance is improved and also enhances evaluation matrices. Also, in starting we saw the problem of subdimensionality. This has also been solved by feature selection technique. This proposed methodology implies that feature selection is essential for classification of high-dimensional datasets to improve model accuracy and reduce computation time. Our proposed methodology is generating an overall increase in accuracy by 45.59% that we saw in the result section. In future, the proposed methodology can be used to validate more datasets. We have currently only four only. Also, the multi-level textual data classification is not addressed in this paper, which we are planning to address in future ones. If you have the references, thank you for your patience.